Hi everyone, in this video I will be demonstrating AI Research Assistant, a modular multi-agent platform designed to support researchers throughout the scientific research workflow. So rather than focusing only on chat which traditional chatbots do, the system helps with the paper discovery, retrieval grounded question answering, paper analysis, literature review generation, and evaluation of retrieval quality. So I will first give you a brief overview of the dashboard, then the architecture, then the walk through the complete workflow using a live demonstration. So let's start with the dashboard now. So this is the dashboard as you can see. This is the search icon to search all the features. This is dark mode, light mode. So if someone wants a light mode, they can just do this, and this is the avatar for you, the user, and this card is for uh, like how many papers I have saved and indexed. And these are the amount of experiments I have done within the system, and these are the amount of chats I have did with the AI research assistant, and these are the amount of research insights I have saved within the system. And these are quick actions, search paper online or through locally, upload paper, literature review, and evaluation, upload paper from here, start evaluation. So as you can see, all this is modular architecture. So what I did is that I organized application into dedicated modules instead of one large chat interface. Each feature corresponds to a stage in the research workflow, making the system easier to extend and experiment with. One aspect I wanted to emphasize is evaluation. So alongside answering questions, system also measures retrieval quality with the latency, groundedness, hallucination, and response characteristics. So different retrieval strategies can be compared, right? Now let's talk about system architecture. So as I already mentioned, it's following modular architecture, but along with that, it's also following service-oriented design for experimentation and extensibility, and system all separates front-end, back-end services, workflow, agent reasoning, retrieval, and evaluation, and etc. into independent components, which means loosely coupled, which is a modern standard. That also means retrieval algorithms, embedding models, LLMs, and etc. can be replaced with a minimal changes in the whole architecture. So the user interacts with the React plus TypeScript frontend. Then it enters the query. The query is gone through fast API backend using REST API. Then on the basis of the nature of the query, it goes either through chat API or analysis API or a literature API. Then, depending on the nature of the workflow, it goes through Q&A or analysis or literature with the workflow router. Then, depending on the work, obviously, so it will uh, different agents will be activated for that task. And as for chunking, embedding and all, three rack systems are getting used: Vector, BN25, Hybrid RRF, and F5s and BN25 indexes are also getting used. So this is the overall system architecture. Now let's start with the live demonstration. So I will go through search paper. Let's start from here. So it searches paper using arXiv. Okay, it's a popular website for all the archive of the papers, famous paper and many papers. So if I write, suppose here I write vision transformers and now search it. Now see, it so quickly tell showed me 10 results, 10 papers, you know, and I can view this PDF. I can download and index it, and it can also tell me, title, the authors, and the year which was published in arXiv, and the abstract of the paper. So it's a very useful feature. Now let's proceed with different features also. Now let's proceed with another feature. So paper library. So a user, after searching and downloading all the papers either locally or from online, it is able to store all the paper with its metadata. And as you can see, these are paper of the user. So he can open this. He can chat with the AI research assistant using this paper. He can analyze it. He can delete it also. So here also it is able to tell the title, the authors, and this indexed status means that document has been processed and is ready for the retrieval. Okay. Now let's proceed to one of the most important part of my project, which is chat. So the chat interface uses retrieval augmented generation RAG rather than relying only on the language model. Relevant sections of the paper are retrieved first, and the response is generated using those retrieved passages as supporting context. So now let's select vision transformer with the quadrangle attention and then ask what is this paper about, and let's choose retriever vector. Now let's send. Now let's wait for few seconds. At the backend, it is trying to going through fast API backend and then going to workflow router, etc. So as you can see, the answer has been generated. What is this paper about? This paper is about assessing the performance of the proposed attention mechanism called quadrangle attention QA, the image classification task. Then you know I think also you can read it to represent attention area, etc. Then one of the most interesting things is the retrieved sources. So each response includes supporting sources so user can verify where the information originated, helping reduce hallucination and making the answer more transparent. So before writing the answer, critique agent, which is part of LangGraph flow, it tries to decrease the hallucination by critiquing the answer before before writing here. Is it even supported claim, right? So you can see these are the sources, and this is a score also. So this was the chat with the research paper. Now let's proceed to another feature. Now let's talk about paper analysis. So beyond question answering, the system can automatically analyze the paper and organize the results into a structured sections. Instead of reading an entire paper from scratch, researchers can quickly review the key contribution, strengths, limitation, and potential future direction before deciding whether to study the paper in more detail. So let's do it. So if we choose, neural machine translation by jointly learning to align, and retriever is hybrid. And now let's analyze paper. It will take a few seconds. Now see how quickly it came. Summary. you know, is able to give summary, propose a new neural translation architecture, RNN search, research problem, improving the performance of neural machine translation, particularly for long sentences, propose solution, RNN search, methodology, encoder decoder, and experimental setup, main results and limitation, future work, important concepts also, tags, neural machine translation, and RNN search architecture, jointly learning, etc. SGD, ADA delta, L2 norm normalization. So it can analyze paper also. Now let's talk about another important feature. Now let's talk about another standout feature, literature review. The literature review module extends beyond analyzing a single paper. Given a research topic, system retrieves multiple relevant papers, identifies the recurring themes, and generates a structured review that summarizes the current landscape of the field. So now let's do it in live demonstration. So I suppose I choose uh, vision transformers in agriculture, and I suppose choose retriever BN25. Now let's generate. It will take few seconds. Now I wanted to show you the generated answer directly on Swagger UI. As you know, a web answer has already been generated on the website, but I wanted to show you on Swagger UI also, so that you can get a more richer idea of how fast API backends and everything is working. So it on the website, as you know, I wrote vision transformer in agriculture, retriever this, and it first of all went to save archive at the website, which earlier we found out papers, paper search, but it is getting used here also. So what it did, it first of all retrieved all the uh, paper related to vision transform and agriculture topic. Then it extracted the text, it chunked them, then it embedded them, then they were used by Landgraph agents like paper summary, theme extraction, and a literature review writer. So paper summary summarized the whole paper. Theme extractor agent extracted the themes related to the paper, and then after every relevant activated agent, we got the whole literature review here. As you can see, scholarly literature review, a field of computer vision has witnessed significant advancement in recent years. As you can see, it has written the whole big literature review here, as you can see. So this is how literature review uh, API works. Now I will show you evaluation API. How do they work? And I think it is one of the most important uh, feature in my project. So let's go. So now let's talk about one of the most important features in my pipeline, which is the retrieval evaluation. So instead of assuming a retrieval pipeline is effective, the system measures different aspects of response quality, latency, citation accuracy, groundedness, hallucination, token usage, right? So this makes it possible to compare retrieval strategies using measurable criteria rather than subjective impressions, which is especially useful during experimentation and system development, right? So so that so retrieval strategies can now be compared objectively also, right? So now I will show you. So we will select a paper, you know, then suppose we choose this, and now we will type the question. and then run the evaluation. To save the time, I have already done this thing. As you can see on Swagger UI, there are many post, you know, posting the question, getting the list of experiments. So each question is now getting treated as experiment. So I will show you this thing. So now delete experiment, get experiment by a ID if you want to just see a one ID, just one experiment, right? And delete that experiment ID. And we can even generate a report also on the basis of that experiment ID, and we can export that report in CSV also, and we can even rank the experiment, and we can even compare the retrievers also. I will show you everything. So first we will get all the experiments, right? So this was the first experiment for the paper, GPT paper, and question was, what is the connection between GPT and transformer? So ID was this, and the retrievers were obviously vector BN25 and hybrid, and result for the retriever vector was the answer this. It gave the whole answer, everything, and it even gave the context also, right? Context also, and what are the sources also? Source chunk ID, this chunk ID was used, what was text in it, and what is the score for it? Paper, source file, gpt.pdf, the chunk ID, text, you know, and below this latency was this, prompt tokens, completion tokens, total tokens, and the matrix latency, as I already shown. Groundedness score was 4. Whatever the supported claims, it even shows the supported claims also. This, and unsupported claims, even this also. And hallucination score also. And hallucinatory claims reason, it also provides. Citation accuracy also. What was the accuracy in citing the paper? So supported by context, missing evidences, reason, token usage, prompt token, completion tokens, estimated output, like what was the cost of using an AI, right? I'm using Grok AI, so that's why it is zero. It's free, right? So, and same for BM25, answer, context, source is chunk ID, text of the chunk, another chunk ID, everything. Then the latency, prompt, completion token, total tokens, matrix, groundedness, score, supported claims, hallucination, reason, citation accuracy, token usage, estimated cost. Now same for retriever, hybrid, answer, context, and everything, so on and so forth. Right? So this was important feature. Now we can delete also, and we can get uh, experiment by their ID. So suppose if I go here and just copy this ID, and now I just try to paste it in get experiment by ID. So we can even do this thing also. Now execute. As you can see, it is also able to tell everything about this, experiment. GPT, what is the connection between GPT and transformer vector, everything. And we can delete this experiment also. We can generate a report also for this experiment ID, and now it has generated the whole report, title experiment report. It has able to tell when it was created, what was the ID, experiment configuration, paper, which paper, what was the question, and top K 5 retrieval, what were the results of the retrieval, vector, uh, metric, value, latency. So it is able to tell everything, right? And even answer also at the end. And obviously we can then export the experiment by ID in CSV also, right? It will be exported, and then we can even rank also experiments, right? I will show you if I put the ID. So it is able to tell latency,
in the context of latency, if it is better in terms of non-lateness, if it is better, that is in accuracy, total token estimated, etc. So it is able to compare also, and we can even compare separately, compare retrieval also, just giving the whole detail of what was a retrieval vector, everything is metadata, latency, non-lateness, and then this data can be used in evaluating uh, what will be which system is rack system is performing good. So this was the evaluation pipeline. Now we will proceed further. Now we will talk about short but very useful feature of the project. Now if someone is talking in this app, the system, research AI assistant, and they close their window. Now they all data will be lost about what they were chatting about, right? But so to prevent this, I have created research memory also. So the memory module stores previous conversations and research notes or insights, allowing the assistant to maintain context across sessions and support longer research workflows also. So as you can see, conversation memory. So question, what is attention? The attention mechanism is this. What is the benefit of the attention? What is this paper about? What is this paper about? What for quadrangle attention? So all this for conversation memory. It is able to store every chat I'm talking to, and this is research memory. So suppose user is studying attention is all you need paper, and he gains some insight about it. So he can then store it here, but his words might be ambiguous. Later, he might get confused by his words also. So, I have created a rewrite agent which will take his insight and convert it into proper research insight. So, suppose if uh, if I write author didn't use RN LSTM and attention is all you need. It's a very simple, ambiguous, uh, very simple insight. So a rewrite agent will rewrite this whole insight. Propose a transformer model that relies solely on cell attention mechanism, eliminating the need for RNN LSTM architecture. So see how is it able to store convolution memory and research memory, and research memory it is able to even rewrite the insight in a better format. So this was my last feature, research memory. Now we will proceed further. Now I will quickly talk about setting page since it's also very useful. So this is just application settings, appearance, system theme, dark theme, light theme, front end stack, React 19, TypeScript, byte, shared CN UI, time stack query, and project AI Research Assistant version 1.0, and AI stack, fast API, LangGraph, quadrant, and sentence transformer, RAG. So this was setting part. So at the end, I will say this project demonstrates a modular approach to building AI systems for scientific research, combining paper retrieval, grounded question answering, structured analysis, literature review generation, and evaluation within a single platform. There are still many directions for future work, including additional retrieval strategies, support for data sources, improved multi-paper reasoning, and expanded evaluation capabilities. And for research paper also, like evaluation pipeline can also be used for you know experimenting on different vector and BM25 hybrid and different rack systems, and then evaluate on them that which is performing good. So this can also be a good scope which I am planning to do next. So this was from my side. Thank you so much for watching this video.